Let's discuss properties of quadratic functions. But first, let me remind you that a quadratic function is written in the form y equals ax squared plus bx plus c. Now I have a graph here of two different quadratic equations. On the left, you have the function f of x equals negative x squared plus 5. And over here on the right, you have the function f of x equals x squared plus 5. Now I want to talk about the differences that occur in the graph based off of these two equations that we have. Now, a parabola, which is the graph of a quadratic, it can open upward or downward. As you can see here on the left, the parabola is opening downwards, and over here on the right, the parabola is opening upwards. Now, do you notice anything about these two functions? What's the difference between the function in blue and the function in green here on the right? Well, the main difference is that the function on the left has a negative sign in front of the first term. Now, how does this change the graph? Well, the negative sign here makes the graph of the parabola open up downwards. Whereas when the coefficient in front of x squared is positive, the parabola opens upward. So what that means is in our quadratic function, right, we have this coefficient term here for a. When a is negative, so I'm just going to put when a equals negative, and then when we have a equals positive. When a is negative, the parabola opens downwards, okay? And just to visualize that, that would be a parabola like this. Now, when a is positive, the parabola opens upwards, and that would look something like you have there on the right, a graph like that. When the parabola opens upwards, right, you have a vertex here at the bottom. Now this vertex is the minimum value of the entire parabola. You can see that no y values go below this point. So I'm going to abbreviate that with min. Now when the parabola is opening upwards, when the parabola is opening downwards here, this vertex becomes the max. Now it's the maximum because no y values are greater than this point, right? Everything is below it. So just be careful. A negative coefficient in front of the squared term, right? A negative a means that the parabola will open downwards and the vertex is a maximum. So be careful. The negative sign doesn't mean minimum. The negative sign with a quadratic actually indicates that there's going to be a maximum point. Whereas when the coefficient of a is positive, you're going to have a vertex that's a minimum. Let's try solving a problem together. A softball player throws the ball from the outfield to third base. The path of the ball is modeled by a parabola. The softball reaches its maximum height 2 seconds after it was thrown. At which time would the softball be decreasing along its path? Now we're told that the path of the ball is modeled by a parabola, so that's one piece of information that we need to keep aware of, or keep in mind. Then we have the softball reaches its maximum height, so maximum height at 2 seconds after it was thrown. So if you want to start to visualize this, right, you would have a graph, and this is going to be very loosely drawn, but you would have a graph that the y-axis is height and the x-axis is time. So as time is increasing, you're going from left to right in this graph. Now the height too. So let's talk about what kind of path this would have. If it's modeled by a parabola, let's just say that 2 seconds is right here on this graph. This would be 1 second and this would be 3 seconds, okay? Now the height is arbitrary. It doesn't matter how high it goes. We're just talking about that there is a maximum at 2 seconds. Now remember, if there's a maximum, then the parabola has to be what? Opening upwards? So would it be going this way or would it be going that way? The maximum means that the parabola must be opening downwards, okay? So I'm going to draw a downward opening parabola, and it would look something like this, okay? Let's say the vertex is here, and this corresponds with the point 2 seconds. This is the maximum point. Now let's talk about different parts of this graph. What happens when you're anywhere in between here on the x-axis? So when x is 0 up until 2. Well, at this point, the ball is increasing in height And you can also tell this because the slope is positive, and this is an increasing slope here if this were a straight line. So in between 0 and 2, or 0 and the maximum, the ball is increasing. Then for a second, at 2 seconds exactly, right at that moment, it hits its maximum height. Now after 2 seconds, it could be 2.0001 seconds. The second that it leaves this maximum point, it's going to start decreasing and falling. So that means that at any time greater than 2 seconds, the ball will be decreasing. Let's look at the options. 1 second, no. You know that that point falls within the path where the ball is increasing. 1.5 seconds is still in that increasing time. 2 seconds is the maximum. So that means 3 seconds is the correct option here, because at 3 seconds, we know that it's past the maximum and the ball must be decreasing either towards someone's glove or it's going to hit the floor. In this lesson, you've learned a little bit more about the properties of quadratic functions. Thanks for watching.